This unit, MOS capacitor, is quite interesting as well as important for few exams. Even though it has very limited topics, but still, this unit along with the first unit, basic semiconductor physics, are the units from where most questions are asked in GATE. However, there are few competitive exams as well where this unit is completely ignored. For solving problems of this unit, you are required good understanding of first two units, which are basic semiconductor physics and PN junction. That's why numericals are quite tricky from this unit, as they might require knowledge of other units as well. MOS capacitor is also the backbone of our next unit, which is MOSFET. What does the MOS capacitor actually stand for? M here represents metal, O is representing oxide, and S is representing semiconductor. And you all might already know that capacitor is a charge storing device. Layers of metal, oxide and semiconductor are placed one after another, which makes parallel plate capacitor because of the oxide, which is an insulator placed between metal and semiconductor. In earlier classes, whenever we have studied parallel plate capacitor, we have taken the area of two plates to be equal. In that case, capacitance is equal to permittivity of the dielectric into cross-sectional area of the plate divided by distance between the two plates. But if the area of the plates is not equal, then we take area of that plate which is smaller in size. The total charge on the two plates will be equal in magnitude. But when the area is not equal, their charge distribution may not be equal. However, for simplicity, we always assume the charge distribution is equal on both the plates, such that the extended region of the bigger plate is not having any charge at all. The capacitance per unit area is equal to permittivity of the dielectric divided by distance between two plates. The magnitude of the charge per unit area on either plate will be equal to capacitance per unit area into potential drop. The terminal at the metal is referred as gate terminal, whereas the terminal at the semiconductor substrate is simply referred as substrate, and sometimes it is also referred as body terminal. It is a general understanding that when we say we are applying a positive voltage, then we actually mean to apply a positive voltage on the gate terminal with respect to the semiconductor substrate. Based on the type of substrate used, MOS capacitor can be classified into P-type MOS capacitor and N-type MOS capacitor. These two types are further divided into two cases. One is the ideal case and the other is non-ideal case. There are two parameters which are very important for understanding of MOS capacitor. One is flat band voltage and the other is threshold voltage. We will study all these things one by one. Actually, the unit of MOS capacitor mostly revolve around these topics. Before moving to the next lecture, I strongly recommend you to revise the first two units.